Hello everyone, let's see a different topic now, that is abstractions from precipitation. So as we know, as a precipitation occurs over a catchment, not all the water converts into runoff or not all the water flows on the surface. So some infiltrates, or we can say some of the water enters from the surface into the soil, and this process we know as infiltration. Some of the water is lost in evaporation, and some of the water is used by the plants in transpiration. So both evaporation and transpiration are studied under evapotranspiration. And apart from that, some depression storage may be there on the surface. So first water will enter into this storage, and then only it will become a part of this runoff. So these are the losses, or as we call them, the abstractions. So now we'll try to understand all these. So first we are starting with infiltration, because it is obviously the most important one out of all these. So we are starting with infiltration here. So infiltration, as I said, what happens as the precipitation occurs over the catchment, the water falls on the surface, and due to the permeability of the soil, it has the capacity so that the water can flow through through the soil, we can say. So the water enters from the surface into the soil, and depending upon the quantity of rainfall, the quantity of precipitation, it will be, the quantity of precipitation will decide that how far this water is going to travel. If precipitation is less, then this water will only be there in the upper layers, and it will just replenish the soil moisture. And if the intensity and the quantity, we can say, if the duration of this rainfall is more, then duration along with the intensity both are more, then this water can enter into the soil and it can travel also downwards. So this groundwater flow starts if the sufficient quantity of rainfall is there. Then groundwater flow will start, and at some point this infiltrated water will join the water table, or we can say groundwater table. So it also supports the stream flow in some cases, stream flow, because of this water table or groundwater table in dry periods, and it also replenishes these aquifers. So that's what happens due to this, all because of this infiltration. So we are interested in the rate of this rate of infiltration, because that's what is going to decide that how much water is going to enter into the soil. So this rate of infiltration obviously depends upon the soil type and other factors. So there are some definitions associated with this infiltration. So we'll try to go into these definitions and try to find this rate of infiltration. So there is this definition, that is infiltration capacity. The unit of infiltration capacity is same as intensity of rainfall, that is centimeters per hour. So we can denote this infiltration capacity as FC. So how it is defined? It is the maximum rate at which a given soil at a given time can absorb water. So it depends upon the soil type and depends upon the time also, that is, if we are talking about just as the rainfall has started, or if we are talking about a time when the rainfall has been there for a long duration. So all these factors will affect this infiltration capacity. So let's say infiltration capacity is FC, and F is the infiltration rate at any time t from the beginning of rainfall and I is the intensity of rainfall. So how do we relate this infiltration rate, and we can also call it the actual infiltration rate and the infiltration capacity, which is the maximum infiltration rate possible. So F is equal to Fc when intensity of rainfall is greater than equal to Fc. So when the rainfall is falling at a rate higher than the soil can absorb, higher than the soil can absorb. What is higher? Rate is higher. So rate higher than the soil can absorb, then obviously the infiltration rate will be the maximum possible, which is possible by the soil. And if this infiltration, or we can say intensity of rainfall, is less than this infiltration capacity, then this infiltration rate is equal to intensity of rainfall. So whatever is falling, it will, the rate at which water is falling, or rate at which the precipitation or rainfall is occurring, it will be equal to the rate of infiltration. When this rate of rainfall, or intensity as we call it, intensity of rainfall is less than the maximum capacity or infiltration capacity. So after that, as I said, that it is, this infiltration capacity is given for a soil, particular soil and other conditions. So obviously there are some factors that affect this infiltration capacity. So factors affecting infiltration capacity that we try to understand. So first factor that we can see here is the characteristics of soil. So this you can easily relate, that is, if the soil is sandy and if the soil is clay, which one would have more infiltration capacity? Obviously the sandy soil would have more infiltration capacity than the clayey soil. And other than that, you can compare if the soil is in dry condition or in wet condition. So obviously the soil which is in the dry condition initially, it will have more infiltration capacity than the soil which is in wet condition. Other than that, you can compare between the soil which is present in some forest or the soil which is there in some urban area. So the factor that comes is, in the forest area which soil is present, it will have more organic matter, and apart from that, compaction is less in case of forest soil, whereas in case of urban area, compaction is more. So if compaction is more, then permeability, or we can say the porosity of the soil, will decrease. So obviously this forest soil would have more infiltration capacity than the soil which is present in the urban area. So these are few of the characteristics of soil which you can relate easily. Apart from that, we can see the surface cover, what surface cover is there on the soil. So if surface cover is there or it is not there, so that will also affect the infiltration capacity. That is, if vegetation is present, then how does it affect? So it retards the flow of water over the surface, and because of that, the water gets more time to enter into the soil. So obviously if vegetation cover is there, then infiltration capacity will be more if you compare it with the surface which is, on which nothing is present, no plants are present. And one more thing is there on this, that is, if nothing is present on the surface, so due to the impact of drops, these drops, whatever pores are present on the soil, on the surface, these pores are clogged, and because of that, it reduces, pores are clogged, so it reduces infiltration capacity. So same thing will not happen if the vegetation cover is present, that you can easily think. And apart from that, there may be some characteristics of water also which is going to infiltrate. That is, if the water is turbid, so obviously it will have more of what? It will be having more of solids in suspension, or they may be present in solution also. So water will be turbid when it is hitting the ground. I mean the rainfall is directly hitting the ground, then there are more chances of turbidity. So in this case the infiltration capacity will be less if you compare it with the normal water. So temperature of water you can think of, because temperature affects the viscosity, but I mean generally it does not come into picture. So these are the factors that affect the infiltration capacity. Now let's move toward the measurement of infiltration rate. Measurement of infiltration rate. So two types of methods or field methods are there, that is flooding type infiltrometer and there can be rainfall simulators. Rainfall simulator. So let's talk about them in brief. So in flooding type infiltrometer, a metal cylinder is used of, so the dia of this cylinder is about 30 centimeters and this total depth of the cylinder is about 60 centimeters. So this is, I mean this cylinder is open from both the ends, so it is inserted into the soil. Let's say this is your ground surface. So here about 50 centimeter is below the ground, and here a water level of 5 centimeter, this is 5 centimeter, it is maintained. So as we pour the water, infiltration will start through the soil. So due to the infiltration, this level will go down here of water. So for that, more water is added, to maintain a constant level. So burette is burette is used for adding the water, so we can measure how much water we are adding, measure the added water. So as the infiltration starts, initially infiltration rate will be more. So let's say this is between infiltration, I mean the graph is between infiltration and time. So initially infiltration rate will be more, and as the soil becomes saturated, infiltration rate will start to recede and it will reach a constant level of rate. It will reach a constant rate. So this is how this process will follow. So this experiment can take up to 2 to 3 hours to conduct, and this data is presented, like this graph is plotted to present the data, and some empirical relations can be used to obtain the infiltration rate. So the problem with this experiment is the fact that because this area is limited, this cylinder's area is limited, so we cannot be sure of that the water will only go downwards. It will obviously go sideways also, and that is not, that is not clearly defining, or it is not clearly showing the infiltration. So to avoid that, there is a modification of this experiment that is known as double ring infiltrometer. So in this double ring infiltrometer, another ring is there. So two rings are there. Say this is the inside ring and this is the outside ring. So here the dia of inner ring is still 30 centimeter and dia of outer ring is 60 centimeters. So here again these both rings are inserted and water is filled in both the rings. So water is there here also as well as here also. So as the now water from outer ring can go downwards and sideways also, whereas there are more chances that the water which is there in this ring, it will go only downwards. So it will present a better picture of this infiltration rate. So here the water level or the quantity of water added is only quantity of water added is measured only is in this inside cylinder, measured in the inner cylinder, we can say. So this will give a better picture of infiltration rate. Now after that, apart from this flooding type infiltrometers, rainfall simulators are also used. Rainfall simulators. So because there are some drawbacks with these ring type or flooding type infiltrometers. First of all, there we cannot measure the impact which will be produced by raindrops, or we can say impact produced by raindrops is not simulated. And apart from that, as we are driving this tube, driving the infiltrometer, it disturbs the soil. So that infiltration rate also disturbs. And apart from that, the size of this infiltrometer, affects the infiltration rate. So these are the few reasons because of which sometimes rainfall simulators are used for the prediction of this infiltration rate. So for that, a small piece of land is prepared of about, this side will be, about 2 meter by 4 meter. And so here if we show in the elevation, so here nozzles are fitted, and from these nozzles water will come out, so it will simulate the, as if the rainfall is happening. So we can maintain the intensity also, intensity of water coming out of these nozzles. And here proper arrangements are made to measure the runoff that will take place through the surface. So we know how much water is coming out of these nozzles, and we know how much water is going as runoff. So by the, with the difference of these two, we can obtain the infiltration rate. So that's how this works. So obviously the basic reason is we can measure this, how much the impact is going to be produced by the falling of these raindrops. Now apart from these field methods, some empirical methods are there to, or empirical equations are there which are used for measurement or for obtaining the infiltration rate equations. So I am telling the name of the few here, that is Green-Amt is there, Green-Amt model, and then Horton's model is there, and then Phillips model is there, Kostyakov model is there. So out of these, for your exam purpose, this Horton's model is used, and Horton's model is asked in the exam, so I'm going to tell you about that alone. So in this model, Horton's model, the equation which is given for the infiltration capacity or infiltration rate at any time, it is equal to F is equal to Fc plus F naught minus Fc into e to the power minus kh into t. So earlier also, as I said, what happens as the rainfall starts? So initially, depending upon the soil characteristics, soil conditions we can write, and the rainfall which was there before. Rainfall happened earlier. There will be a initial infiltration rate, which will be mostly. So initial infiltration rate, let's say it is F naught, and then as we saw in this graph, so here this is between infiltration rate and time. So initially this infiltration rate is more, that we are telling as F naught, and then this infiltration rate decreases and then it reaches a constant value. So this constant value of this infiltration rate, let's say it is Fc. So what is Fc? It is a constant infiltration rate, let's say, I mean initially this point where this infiltration constant infiltration rate is being achieved is Tc. So it is a constant infiltration rate and we call it as ultimate infiltration capacity. So this equation obviously gives a relation between this F naught, Fc and F. So what is F? F is the infiltration rate at any time t. So the range of this t, I mean for which this equation has been defined. So the range of this t is between 0 to t and it should be less than this Tc. So it up to here only it is defined. So here this kh is the Horton's decay coefficient, and so this decay coefficient depends upon the soil characteristics and what kind of vegetation cover is there. So it will depend upon that. So how do we obtain these parameters of this equation? So as we saw that double ring infiltrometer test, so what the data we get out of the test, that data can be used. So for that the basic equation here is, F is equal to Fc plus F naught minus Fc into e to the power minus kh into t. So this equation is converted as F minus Fc is equal to F naught minus Fc e to the power minus kh into t. Then ln is taken, so ln F minus Fc is equal to ln F naught minus Fc minus kh into t. So a graph is plotted between this ln F minus Fc and t. So on this, here it will be ln F minus Fc and here it will be t. So it will form a line. So intercept of this line will give this ln F naught minus Fc intercept. This is the experiment which is conducted, and with the help of this double ring infiltrometer data that I am telling just for your knowledge. So the slope of this line can give you this decay coefficient. So this is the basic idea about this Horton's equation. So we'll solve some example based upon this equation, and then we'll see the infiltration indices also after this lecture. Thank you.